right, doing this problem called binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. Okay, so this is a typical, like, I mean, I don't know if this is a very basic, typical textbook algorithm. You use a queue and you keep the element in the queue. So if I talk about it, what you essentially do in level order traversal or a DFS is that you would use a queue. You'll add the first element into the queue. So 3 is the first element into the queue. And then what you do is you pop that guy out. So this is my queue, okay? So this is my queue and this is what I am print, right? So I'll pop the element out of the queue. So I'll remove the element out of the queue and I print it. And both its children I'll insert into the queue. So 9 and 20 will be inserted into the queue. Then I take one element out, I pop it, I like print it, and its children will be added into the queue. So 9 did not have any children, nothing to do. Then I remove the element out of the queue, 20, print it, and push its children into the queue. So 15 and 7. And now we'll dequeue each of them. 15, I'll print it, and again 15 does not have any child, or does it? Yeah, it does not have any child. Then 7, and then we'll basically do this till our queue is empty, right? So it's a very basic level traversal. I don't have to print, I have to put it into a list. Okay, so I'll create a, why is it a list of list? Why is it a list of list? Okay, I have to print it in this format. I have to print it first level, second level, third level, and so on. All right, interesting. So let's call a list of integer, call it as result. First new array list, and obviously we'll need a queue. So queue of integer, let's call it queue equals to new list. We're gonna do queue dot add the root, right? And then we're gonna do while my queue is not empty. And now at any point, whatever is the number of elements in the queue, like in the outer while loop, that's the level, right? So in the first case, I'll have 3, I'll pop 3 out, then I'll put 9 and 20, right? So I can get like a size of the queue here. So size equals to queue dot size, and I can create like a list here. So a list of integer, or rather I can do, yeah, I can do a list of, I can call it level equals to new array list, and then for I equals to 0, I less than size, I plus. I'm gonna do what? I'm gonna do but okay, before this, if my root is empty, I don't want to put null guys into the tree. So if um, yeah, what are you returning for root equals to null? Returning an empty list, is it? So if root equals to null, just return a result. Okay, now root is not null. So for each thing, I'm gonna do what's the representation of root tree node. Okay, so tree node node equals to remove an element from the queue, and this element will be added to this level. So level dot add node dot val, and if node dot left is not equal to null, q dot add node dot left, and similarly if node dot right is not equals to null, then you add that as well. and you add in the result, you add this level, and at the end you are gonna return the result. Let's run and see if it works. Compilation error. Q dot add root. So cannot be converted to integer. Okay, that queue that we are maintaining is a queue of 3 nodes. I'll run again. Okay, seems to work. Submit.